All right, let's crunch some numbers. We're deep diving into chapters 1 and 2 from Essentials of Modern Business Statistics with Microsoft Excel. So get ready to see how all this statistical stuff is actually used out in the real world.
It's interesting how this book focuses on applying the concepts, really showing how it all works in business and economics.
Yeah, makes it practical, right? I get that formulas are important, but seeing how businesses use them to make decisions, that's what makes it click for a lot of people, I think.
Absolutely. And chapter 1 really jumps into those real-world examples right from the start. They even talk about how Bloomberg Businessweek uses statistics, not just in their articles, but internally, too.
Oh, right. They mentioned using those subscriber surveys to figure out what kind of content people want, basically using data to make smarter choices.
Exactly.
Okay, so speaking of data, chapter 1 really breaks down what data is and how it's organized. They use that example of the World Trade Organization with data on 60 different countries.
Yeah, the WTO data. It's a great example to see how a whole data set is structured.
It helps to understand the different parts, right? Like elements, which are like the individual things you're collecting data about. In that WTO case, each country is an element.
Yeah, and then you have your variables, which are those specific characteristics you're measuring for each element. Like for those countries, it could be GDP, population, even things like their credit rating.
And then each country has a set of all those measurements.
Right.
That's what they call an observation.
Exactly, like a snapshot of all the data points for that specific country.
Now, the book gets into these different ways to measure those variables, these measurement scales: nominal, ordinal, interval, and ratio. These always kind of trip me up back in school.
I think a lot of people get hung up on those, but they're important because they tell us what kind of analysis you can do with the data. Nominal is the most basic. It's really just categories or labels.
Oh, okay. So like colors or types of cars.
Exactly. Or even just yes-no answers. There's no ranking or order to them.
Okay, so nominal is just about names or labels. Then there's ordinal. What's that about?
Ordinal data, that does have an order, but the differences between categories aren't necessarily equal.
Mm-hmm.
It's like, say, ranking your favorite movies. You can say you like one better than another, but you can't really say how much better. The book uses credit ratings as an example. AAA is better than AA, but it's hard to say precisely how much better.
Gotcha. So it's like a ranking system where the gaps don't necessarily mean the same thing.
Yeah.
Then there's interval data, right? What makes that different?
With interval data, the differences between values are consistent. Like temperature, the difference between 20 degrees and 30 degrees is the same as between 70 and 80, but there's no true zero.
So 0 degrees doesn't mean no temperature.
Right, it's just a point on the scale.
Ah, the gaps mean something, but 0 doesn't mean nothing. Got it. What about ratio data then? That one sounds even more complicated.
Ratio data, it's similar to interval in that the differences between values are meaningful, but this one does have a true 0 point. Like with height, weight, or income, 0 height actually means no height. And you can say someone who's 6 feet tall is twice as tall as someone who's 3 feet tall.
Interesting. I see how these scales really change how you look at the data. It's not just the numbers, but what they represent.
Right.
But before we get too deep into the analysis, I'm curious, where does all this data come from in the first place?
That's a great question. Chapter 1 outlines different sources. Sometimes you've got existing data ready to go, like internal sales records or customer databases. There are also those market research firms like Nielsen or Bloomberg, where you can actually buy data.
And I bet government agencies are a goldmine for data, too.
Oh, absolutely. The Census Bureau, for example, collects a ton of data on everything from demographics to economics.
Wow.
And of course, we can't forget the internet. I mean, it's a vast ocean of information if you know where to look.
Right. But what if you can't find exactly what you need from those existing sources?
Well, then you might have to collect your own data. One way to do that is through observational studies, where you're just watching and recording what's happening naturally, no intervention.
Interesting.
Like imagine watching shoppers in a store to see how they interact with products or tracking website traffic patterns.
That's like being a data detective. The other way is through experiments, right?
Exactly. With experiments, you're manipulating variables to see how they affect an outcome, like that example in the book with Rogers Industries testing those 200 batteries to estimate their average lifespan.
Right, with that new technology they're trying out.
Yeah, they're controlling the conditions to see how the new tech affects battery life.
I can imagine those experiments can get pretty expensive and time-consuming. Is it always worth it to go that route?
Not necessarily. Sometimes using existing data is just more efficient, even if it's not perfectly tailored to what you need. It's a balance, you know?
Yeah.
The cost, the time involved, and how accurate and detailed you need to be.
And even then, there's always a chance of data errors, right?
Absolutely. Like they say, garbage in, garbage out. If your data is bad, your analysis is going to be flawed. So careful data collection and cleaning are really important. You got to make sure it's reliable before you even start crunching the numbers. So you've got your data, it's all cleaned up, nice and accurate. What's next? Well, Chapter 1 gets into this idea of descriptive statistics. It's a way to make sense of all those numbers.
Kind of like summarizing a really, really long book. You want the main points without reading every single page.
Yeah, that's a good way to think about it. Descriptive statistics is all about taking a huge amount of data and boiling it down to something manageable. You know, you might use tables, charts, even just a few key numbers to summarize what's going on in the data.
Instead of staring at a giant spreadsheet with hundreds of rows, you're making a snapshot, picking out the important trends.
Exactly. Like, remember those credit ratings we talked about? Imagine trying to understand the credit outlook for 60 different countries just by looking at a list of ratings. A descriptive statistic could tell you that, say, 75% of them have a stable outlook, which gives you a much clearer picture right away.
Right, or you could make a chart showing how per capita GDP is spread out across those countries. You could quickly see if most countries are kind of clustered together or if there's some way out there on their own.
That's what's great about visualizing the data. And that leads us to another important concept from Chapter 1, statistical inference. It's like taking those summaries a step further, using them to make predictions about a bigger group.
Oh, right, like how Rogers Industries used those 200 batteries to estimate the average lifespan for all the batteries they make with that new technology.
Exactly. They're using a sample to make guesses, inferences, about the entire population.
And that single number they came up with, let's say it was 18.5 hours, that's called a point estimate, right? Their best guess based on what their sample showed.
That's right.
But there's always some uncertainty, right?
Yeah.
I mean, they only tested a small chunk of all the batteries they're making.
Right, and that's why they also give an interval estimate, a range of values where the real average lifespan is likely to be. They even attach a confidence level to that range, like we're 95% confident the real average is somewhere between 18.1 and 18.9 hours.
It's like saying, we're pretty sure it's in this range, but we can't be 100% certain because we only looked at a sample.
Exactly.
Now, Chapter 1 also mentions how important tools like Microsoft Excel are for doing all this.
Especially for businesses, knowing Excel well can be a huge advantage.
It's not just putting numbers in a spreadsheet anymore, right? Excel has so many tools for analyzing and visualizing data.
It's like having a mini statistics lab right there on your computer.
That's a great way to put it.
And speaking of making data work for you, Chapter 1 brings up the idea of analytics. It's basically turning data into insights you can use to make better decisions.
I feel like that's the whole point of all this, right? Not just the numbers themselves, but what they tell us and how we can use them to improve things.
Exactly. The book breaks analytics down into three main types: descriptive, predictive, and prescriptive. Descriptive analytics is all about understanding what happened in the past, like looking in the rearview mirror. Think sales reports, customer demographics, web traffic patterns.
So using data to tell a story about what's already happened, which can then help you plan for the future.
Right. Then you've got predictive analytics, which is using past data to try and figure out what might happen in the future. Businesses use it to predict things like sales trends or how a marketing campaign might do.
And then prescriptive analytics, that one sounds like it takes things a step further.
It does. Prescriptive analytics is all about figuring out the best course of action based on the data. It's like having a data-driven GPS for your business decisions.
Like using data to optimize pricing, personalize marketing, or even streamline your supply chain.
Exactly. It shows how data can be used to make smarter decisions across every part of a business. Now, remember all that talk about the crazy amounts of data being created these days? That's where big data and data mining come into the picture.
Big data still sounds like a buzzword to me. What does it actually mean in a practical sense?
Think of a company like Amazon. They handle millions of transactions daily, collect data on everything you click and search for on their website, track customer behavior across multiple platforms.
It's overwhelming just thinking about it.
It is, and that's basically what big data is, this huge amount of data. But it's not just about the amount. The book talks about the 4 V's: volume, velocity, variety, and veracity.
Okay, break those down for me. What do they all mean?
Volume is pretty straightforward. It's the sheer amount. Then you've got velocity, how fast the data is being generated and needs to be processed. Think real-time stuff like social media or financial markets. Variety refers to the different types of data. It could be structured data like numbers and dates, unstructured stuff like text and images, or even semi-structured data like sensor readings.
It's definitely not just numbers in a spreadsheet anymore. It's all kinds of information you can use to get insights.
Exactly. And then there's veracity, which is all about how accurate and reliable the data is. With so much data coming from so many places, you got to make sure it's a good quality data.
Otherwise, it's back to that garbage in, garbage out problem.
Exactly. Now, when you have all this big data, you need a way to make sense of it. That's where data mining comes in. It's like digging for gold in a mountain of information, looking for those hidden patterns, correlations, trends that can help you understand your customers or predict future outcomes.
You're taking all that raw data and turning it into something you can actually use.
Precisely. Think about how Amazon suggests products you might like based on your past purchases, or how financial institutions detect fraud. They're using data mining.
There's so much potential there, but it sounds like you need specialized skills and technology to do it right.
You do. It uses a lot of statistics, machine learning, and sophisticated software. But that's a whole other deep dive.
Right.
For now, let's shift gears and dive into Chapter 2. It really focuses on descriptive statistics and using tables and graphs to show the data visually.
Sounds good. Let's get visual.
So Chapter 2 starts off with a simple but powerful tool, the frequency distribution. Basically, it's a table showing how often different values or categories pop up in a data set.
So like if we were looking at those 50 soft drink purchases, our frequency distribution would show how many went for Coke, how many chose Pepsi, and so on.
Exactly. And you can also look at the relative frequency and percent frequency, which tell you the proportion or percentage of each category. So instead of just seeing that 19 people bought Coke, you see that it's 38% of all the purchases.
That puts the numbers into context. But sometimes, like they say, a picture's worth 1,000 words. What about showing those frequency distributions visually?
That's where bar charts and pie charts come in. A bar chart uses different sized bars to represent the frequency or percentage of each category. It's great for comparing categories side by side.
I always find those easy to understand. You can immediately see what's most common and how things compare.
Then there's the pie chart. It divides a circle into slices for each category. Good for showing how the whole is split up, but can get a bit messy with too many categories.
I could see that. Now, Chapter 2 also talks about how to make these charts in Excel, which is handy for anyone who wants to try this stuff out themselves.
Right.
But what about when you've got quantitative data, not just categories? How do you make a frequency distribution for something like those audit times at Sanderson and Clifford?
That's where it gets a little trickier. You still use a frequency distribution, but you have to group the data into classes or intervals. So instead of listing every single audit time, you might group them into ranges like 10, 14 days, 15, 19 days, and so on.
So you're creating buckets for the data and then counting how many fall into each bucket.
Yeah, exactly. The book has some guidelines for how to choose the right number of classes and how wide they should be. It's about finding a balance between detail and keeping things manageable.
Sounds like there's an art to it, not just a formula. But what about visualizing quantitative data? Are there ways to do that, like bar charts and pie charts?
Absolutely. Dot plots are a good way to start. Imagine an axis representing the range of values, and then each data point is a dot above its value.
So you see all the data points individually, you can see where they cluster, and if there are any that are far off from the rest.
Right. And then you have histograms, which are like bar charts for this type of data. The bars touch each other, which shows the data is continuous, and the shape of the histogram tells you a lot about how the data is distributed.
What kind of shapes might you see, and what do they mean?
Well, a symmetrical histogram has that bell-shaped curve, means the data is evenly spread around a central value. A skewed one might have a long tail on one side, meaning the data is more concentrated at one end. And then you might have a bimodal histogram with two peaks that suggests maybe there are two distinct groups within the data.
So the shape can give you clues about what's going on in the data.
Exactly. The book also has examples of making histograms in Excel. Then there are cumulative distributions. They show how many observations are less than or equal to a certain value.
So for those audit times, it might tell you 80% were done in 25 days or less.
Exactly. And lastly, there's the stem and leaf display, kind of old school, but helpful for smaller data sets.
Oh, yeah, I remember those. The stem is the first digit, and the leaf is the last digit.
Right. Compact way to show the distribution and still see each data point.
Now, we've talked a lot about summarizing data for one variable, but what about when you're looking at the relationship between two variables? How do you deal with that?
That's where cross-tabulations come in. Think of them like frequency distributions, but for two variables at the same time.
Like going back to those restaurants with their prices and quality ratings, a cross-tabulation would show how many restaurants are in each combination. Like how many have excellent ratings and prices in the 50-60 range.
Exactly. And you can calculate row and column percentages to see the relationships. You might find that a higher percentage of expensive restaurants have excellent ratings compared to the cheaper ones.
So there could be a link between price and quality.
Right. Now, Chapter 2 mentions this thing called Simpson's paradox. It's really interesting. It shows how combining data from multiple cross-tabulations can be tricky. Sometimes the conclusions you get from the separate tables are reversed when you put the data together. Shows you got to be careful and look deeper. There might be hidden variables at play.
It's like a statistical plot twist. So we have our cross-tabulations, but how do we actually visualize the relationship between those two variables?
That's where scatter diagrams come in. They're great for seeing the relationship between two quantitative variables. Remember that electronics store in San Francisco?
The one trying to figure out if running more TV ads leads to higher sales.
Yep. They wanted to see if there was a correlation.
Right.
A scatter diagram would plot the number of commercials on one axis and the sales on the other. Each week would be a point, and you could see if there's a pattern, like an upward trend.
Showing that more commercials mean more sales.
Exactly. You can even add a trend line to really highlight that relationship.
Okay, makes sense. And if we're dealing with two categorical variables, we can use those bar chart variations, right? Like side-by-side or stacked bar charts.
Right. Side-by-side would show bars for each category of one variable grouped by the other, like bars for each price range grouped by quality rating. Makes comparing easy.
And a stacked bar chart would take each bar and divide it up to show the breakdown of the other variables so you can see the composition of each category.
Exactly.
Chapters 1 and 2 have given us a lot to think about, the different types of data, how to summarize it, and to visualize relationships. Before we move on to those glossary terms, though, Chapter 2 really stressed best practices for data visualization. Why is that so important?
It's not just about making charts and graphs. They have to communicate the important information clearly. Picking the right type of display, using clear labels, avoiding clutter, these are all things that make a visualization effective.
It's about telling a story with the data, not just throwing a bunch of numbers and charts at someone.
Exactly. And they talk about data dashboards as a good example of bringing it all together. It's like a control panel for your data.
They use the example of that IT call center at Grogan Oil.
Yeah, their data dashboard tracks things like call volume, resolution times, even types of problems, helps them make sure they have the right people to handle the work.
And it's all visual, right? Easy to understand at a glance. Speaking of which, before we wrap up, let's run through those glossary terms from chapters 1 and 2. They can feel like a whole other language sometimes, but you got to know them to really get into data.
You got it. Let's start with Chapter 1, Analytics.
Okay, let's do it.
All right, for all the data nerds out there, let's recap the technical stuff. Chapter 1, it's all about the foundation, right? Data is everything, and you got to understand the different types, like nominal, ordinal, interval, and ratio. Those scales, they tell you what kind of analysis you can actually do. Then we talked about where that data comes from, all those different sources, databases, studies, experiments even.
And even with the best data, if it's not accurate, you're in trouble, right? Like you said before, garbage in, garbage out. Cleaning that data is super important.
Absolutely. Now, once you have good, clean data, Chapter 1 gets into those big concepts, descriptive statistics and statistical inference. Descriptive statistics, that's all about summarizing, boiling down the data to something you can grasp, using tables, charts, or just key numbers. Statistical inference, that's where you use that summary to make educated guesses about a bigger group, taking what you learn from a sample and applying it to the entire population.
And we saw how real companies, like Bloomberg Businessweek, use this stuff to make decisions, like figuring out what content people want or understanding the market. But this isn't just for big companies, is it?
Nope, not at all. Chapters 1 and 2, they give us tools that anyone can use. Think about it. We see data every day in the news, on social media, even in our own personal finances.
Yeah, it's true. Now that you mention it, I'm starting to see data everywhere. And knowing about those different charts and graphs, like bar charts, pie charts, histograms, scatter diagrams, that all helps make sense of it.
Exactly. Visualizing the data, it can reveal patterns you wouldn't see just looking at numbers. And for those who want to go even deeper, Chapter 1 talks about big data and data mining.
Those are pretty hot topics these days, all that information online.
Right. Big data, that's all those massive data sets, way too big for traditional methods. Think social media, online shopping, even all those sensors and smart devices. It's a ton of information, but you need special tools to make sense of it.
And that's where data mining comes in.
Exactly. It uses statistics, algorithms, and software to find those hidden patterns in all that data, like finding clues to understand your customers or optimize your business, even predict things.
Well, it's powerful stuff, but it sounds kind of intimidating, to be honest.
It can be, but you don't have to be a data scientist to benefit from this. Even a basic understanding can help you make better decisions in your life.
That's good to hear. So for our listeners who are maybe thinking, okay, this is cool, but what does it all mean for me? What's the main takeaway you want them to remember?
I'd say the biggest takeaway is this. Being able to understand and use data, it's becoming more and more important. It's not just a specialized skill anymore. It's something everyone can benefit from.
I totally agree. And chapters 1 and 2 have given us a great starting point. It's not as mysterious as it seems.
Definitely. And this is really just the beginning. There's so much more to learn about statistics.
Well, that brings us to the end of our deep dive into chapters 1 and 2. Hope you all enjoyed it.
Me too. It's been fun.
And to everyone out there, keep exploring, keep asking questions, keep unlocking the power of data. Until next time, happy analyzing.